wanted to check what kind of other coding emulations there are. Let's see. Automation, signal state, circuit boards. Those are fun. What's this about? Output 7. What language is this? Ah, but you can't type. What do you mean? Okay. No, let's see. I like the circuit ones. That one looks interesting. But you know what? There are some what do they call them? Code puzzles. God, what is that? Code Academy? Sure. What to do, what to do. Cybersecurity even. Let's do some Python. Let's see. Friendly. We'll do basics. Go into basics. Let's see how far we can go. Instructions. Change code academy to the name of the script. Huh? Run the code, see what it does. To your name. Oh, Chris? That's it? Oh, right. Easy. As soon as you're ready, move to the next. Yeah, okay. So use a variable. Ironically, the first thing we're going to do is how to tell a computer to ignore a part of a program. Just a comment. Easy. I mean, stuff. Var, sum var equals 5. Okay, easy. Print something. Okay, there's something in the soul. Print distinguished greeting from hello world. Print the distinguished. Did you print? No. Now we're going to do is teach your computer to communicate. Print. I'm not. Print distinguished. Oh, you want me to do specifically? Uh-huh. Really? Really? That's it? That's all you're gonna give me for that? Buh. Control flow, lists, loops, functions, Python challenge, optional strings, all locked for free. That's pretty boring. So I have to actually pay for that. Okay, well, let's go to Joy Programming now. That was useless. Everything's behind a freaking paywall nowadays, man. They give you like 4 things. All right. Let's see. Hacking. Is this a brute force? That's pretty cool. We lost the pin to this. Now we gotta find the pin to this crack. The safe. Enter code, check pin, incorrect, greater. Pin code in 10 tries or less. Must be between 0 and 99. Crack the pin code in 10 tries or less. Other than brute forcing this, which would not take 10 tries, unless it tells me which numbers are correct. But since we have 999 options. Alright, what happens if I try out check pin greater than less than the real convenience synchronous blocking only works in Python. How can you check pin? So what is it going to do when I check pin? So safe equals pin hacker dot entity pin hacker 0 and safe dot check is greater is going to be the value that changes. Get is greater check pin guess we're just gonna go with get first. Or just first. Alright, so we got the safe in our variable. Now we do check pin. And if I do 555, run that. Gotta reset this. Current time. It's a loop. Is greater 1. Alright, so we do a pin. We'll have to use halving methods. So we check the middle. If it's higher, we go to the next middle. If it's not higher, we go to the below middle. Get is correct, get is greater. Okay, so if safe dot is get is greater. So if it's greater, let's say we start off with number or pin equals to 555. We check pin. If it's greater, we want to divide by 2 and add to the original, but we have to make sure we're using integers, so we got to round or at least convert to an int. So pin is going to equal to int of pin plus pin divided by 2. If, well, or else really, because there's only either higher or less than. Pin is now going to be integer of pin minus pin divided by 2. Let's print the pin to check its value. Five 832. Oh wait, it's going too far. Okay. That makes sense because we keep going higher in the valuation. It'll probably work for smaller values, but can't go above 999. Maybe we got to get the difference between 999. So max equals 999. So we want to get the difference between the pin now and the max for the upper bound. So max minus pin, then divide by 2. That would give us the difference. And then we can divide that by 2 to get to the halfway point. For the other case, if we get smaller, it should be okay because the pin itself gets smaller and continues to half. Seven 888. Current time 943. Higher. Is it really that? It can't be. Hold on. And safe dot get is correct and not so if it's not correct, and if we find it correct, then yeah, should be universal there since it's a global variable. 557788 keeps going. Okay. Let's try again. Pin has been changed. Why is it that if it's equal to 1 then? Because right now, what is it? It's greater? Oh, wait a minute. I have to go down. So the number is greater than, so I gotta reduce the logic. Or revert the logic. Flip the logic. So this number is greater, not the pin is greater. Uh-huh. Okay. So the logic's better. Now, on the decreasing side, hold on. On the decreasing side, I don't want to find the difference, max pin, adding. God, what was that case scenario? So if it's 555, it's too large, we cut it in half. I gotta save a last. Because the last in the history phase. So then last equals pin. So that'll tell me where I was before. And the current choice. And if it's greater, I use the last to make my max. Maybe I can change my max to the last. Maybe I can just use max in general and just keep changing max itself. So if it was 2755, or it was like 555, and then we go down to half of that, then we need to have the max as 255 because we don't want to go beyond it. So if we're going greater, max now equals to last. But we want, no, hold on. Because then if it's bigger, yeah, let me see. Because if it's bigger, we got to use max as a reference point because we don't want to go beyond max. There we go. 485, 242. Ah, but then 242 breaks it back down. Okay, and then it halves it later. Okay. So halving wouldn't always work when it's greater or when it's less. So I need a lower too. So max, low. So current pin. The downward is a little bit different. Let's see. If we go down, we don't want to cut it. If I have to go just a little bit down, I have to find the difference between the last low before it got greater and the current value, the current pin. Yeah, the difference of. And then divide that by 2. So pin minus low, just like that. So that way we don't cut it directly in half, but then I have to make sure the logic then low would equal to hold on, last, and then we take the difference, which would be some value between the pin current and the low that we had last time, subtract it, divide it by 2, and try that. There we go. Okay. Hey, it's gold. Oh, but I want... Okay, well, because I didn't really reset this. I didn't reset the whole thing, so I should be able to find that pin now within 10 values. With the same script. No changes. $33, but 11 tries? Come on. That's not even fair. Was one off. Lame. Time beats. Damn. Did it faster than 99%? Okay, let's try that again. Maybe it was just an unfortunate number. Oh, 855. Yeah, unfortunate number. 10 tries. Got it. Nice. Well done. Next. Packet sniffer. Let's see. That's fun. So we got a bot over here. What's your name, bot? Entity data exchange. Decrypt the intercepted message and enter the passcode contained in the decrypted message. We know that the intercepted messages always end with good luck. Submit the correct. So it's kind of like a sincerely. Submit the correct passcode into the data exchange with the key passcode. Oh, okay. Store big set data. Remove data RPC. Alright, well, what do we have? Nothing. Ugh, data exchange. Not used to using these. So, store big data. Click to apply changes and copy code to set the value of this actuator. Number 5.6 stats, time, distance 12. Remove data number. Make an asynchronous remote procedure call. Correct passcode into the data exchange. So retrieve data from the exchange for the specified key. Okay. So first I need to grab the information being sent. So let's print that out. So we're gonna call this stream equals data exchange data. Let's pass it data exchange first. So yeah, grab the. Well, let's see. Data x equals to data exchange dot first. Get data. So what's inside of this? Data exchange dot get data. Missing argument key. Okay, so this is a potential check then. And we throw in number 5.6 set data. Okay, so fine. We gotta first set it. Data x dot set data. And it's an array. No, it's not an array. It's the number and then comma the value of that number. Let's see what this does. Right, then I gotta do this. Set number in here for the actual grab. Current time. What? That's it? Okay, so we set data on this database, number 5.6, then we call it back. Great. Make an asynchronous remote procedure call. What's RPC do? Return RPC. Make a synchronous call. Procedure call. What's it expect? Function name. So this function's inside this. Click to apply changes and copy code to set the value of this actuator. Decrypt the intercepted message and enter the passcode. So I gotta find this message. Where is it stored? What if I just do data exchange? What's the print on data exchange look like? Entity, that's it. Alright, so it just tells me the entity. Wait, what about... I haven't taken a look at this thing. Ah, okay. Message sniffer entity. Then there's the message. Get the intercepted message. It contains a hidden message. It's encrypted with a simple Caesar substitution cipher. Okay, that's enough information. Meaning the encryption key must be a new natural number. For example, the message ABX encrypted with the key 2 would be CDZ. Okay, so that's what a message is. Not in here. So we get encrypted message equals to message sniffer dot first figure out what the substitute key is, then decrypt. So we gotta find the sub key. So Caesar cipher is pretty straightforward. So in an alphabet, if I have a sub key of 2 and I use the letter A, it's gonna move that value up 2. So instead of A, we move to B and then C. That movement of 2 letters is now going to be C. So that's why it's saying ABX encrypted with the key 2 would be CDZ. B goes up by 2 as well, so that'll be BCD and then XYZ. So every 2 subkeys, our value adjusts. Which makes things difficult for certain things. Well, the thing is, like, it'll do it for us, so we don't have to move bits around. Normally, you would actually physically or programmatically move bits around to test out the whole sentence and see if it works. So in this case, all I really have to do, try decrypt subkey values until I find the right one. So in this case, encrypt message dot try decrypt of key. We'll start key at 1. Print encrypted message dot try decrypt. So we'll print out the decryption, and then we'll increase key by 1. So key equals to key plus 1. And this will just kind of go forever and decrypt. Substitution key. Oh, I didn't. What? Oh, wait. Duh. I mean, I'm kind of doing it, but I didn't do it. I didn't do it right. I didn't save it and move it. Okay. Doesn't look right. Doesn't look right. Doesn't look right. Nope. 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 8, 9, 10, 11, 12, 13. Oh, what I can do, since we know that good luck is the end, I can search the string and see if I find. Oh, I forgot how to do that. Python is in string. Contains? Contains block, continue. So I can just do it directly. And then I'll test if good luck in we gotta save this encrypted message decryption so we can test it in its own variable. So decrypt message equals boom. We can still print it, but then is good luck in decrypted message, we can break out of the loop. And then break and decrypt the cipher offline, then enter the passcode on your first try. Okay. So basically don't reload the script multiple times. Which means I would have to find digit values. So let's try this for now and then I'll go to the next steps. So then we're going to print decrypted message. In fact, I shouldn't have to print continuously. I should be able to just do this straightforward and it'll print the finalize. So try. So always when decrypting, cracking, and all that jazz, you have to have an idea of what the actual result's gonna look like. So normally you test for words. The, is, quick, common words you would see in a message. Once you decipher and you find that word, there it is. Nice, okay. So we found the passcode. Now we gotta enter it into the data exchange. So I'm trying to go on a first try basis. So I found the specific set. It's 26. It's gonna be different every single time we reload. Now, since I know there's going to be a quote around the passcode, I can splice by strings. Split? Was it split in Python? Split by delimiter? Yeah, it is split. So then, once we have the message, we can take a passcode equals decrypted message dot split by quotes. And we're going to take the first value because the split's going to split into 3 pieces. The first split's going to be on the left of the quote. The second split's going to be in the middle, and then the third split after the quote. which means there's 0, 1, and 2 values in this array that's being created, split. 0 is the first section before the quote, 1 is between the quotes, and 2 is going to be after the quote. And since that's the last quote, it would be the highest value. So I'm looking for that middle section between the quotes, which would be the 1 location in the index. After that, submit the correct passcode into the data exchange. Then I gotta talk to this data exchange. Okay, so what is this? With key equals passcode. Set key and then passcode? Stats time. Distance ID. I'm not too used to using this data exchange. So maybe data has to be key and then the value. So let's try that, because I already have that set up somewhere. Oh, I haven't reset it yet, right? So now we'll take our data exchange and then that set data key, comma, passcode. So let's run this. Should be the same exact thing. Should be 26 times before it cracks it. Digital ghosts haunting the screen, binary dreams. Ciphers crumble as I scheme, cracking the seams. Fingers dance, spider legs across keys unseen. Firewall crumble, the fortress turn a meme. So now data exchange should have the value key. Oh, well, it has 2 values now. Okay, that's fine. So it should be then a reset, and then we can try it. Offline. Then enter the passcode on your first try. What do you mean offline? I'm confused. I only grabbed it once. Okay, so I did find the key and I entered it. But why is that other thing still there? Why is numbers still in there? Let's do a data exchange dot remove data number. Because maybe I didn't actually remove it from the last time. Should have removed it now. I'm confused at what offline means here. Huh? Oh, okay. Why didn't it remove number though? Try decrypt. Literally decrypted on the first try? Offline, what does it mean? Value equals the passcode. Submit the correct passcode into the data exchange. Value equals the passcode. Key equals that. Oh, key value pair. I see what you mean. All right, so basically, I'm a little dumb. This should be passcode as the key of the, because it's technically, when we're setting the data, we're actually setting it inside of a dictionary list. And a dictionary has a value colon key pair. Or sorry, key colon value pair. Dyslexia. So I was reading this like I had to put key and then passcode like this, but technically in the key in the first part of each dictionary list value should be passcode. And then that second one should be actual password. So this key should actually be passcode, not the word key. Which means passcode, passcode. That should be basically it. But then that's gonna work. I just don't understand what this break and decrypt the cipher offline. Is that like me not using try decrypt and making my own manual decryption? So instead of using the try decrypt, because that would mean that's probably an online attempt, that would mean I would need to manually move the bits for each key in the system. But that didn't work either. Okay, let's get this again. Data exchange. The mechanics of some of this is very weird. So let's remove, maybe I have too many things in data now. So data x dot remove data, we're gonna remove number. Clean up my data. We're gonna remove number, key, and the passcode bits there. Which this should be gone now. Key's gone. Why is key gone but the other two are not gone? Hello? Number is still there. Key's gone. Huh? That's what I'm doing. Is it a mix match of types? If I use single colon. Makes no sense because I used the quotes and it worked fine. Okay, so what's now if I do data exchange dot get data? It's gonna return the whole thing still. But then I have to throw in something in there. But I put a key in there. What do you mean? Quotes messing up? Oh, I'm not printing it though. Hold on. Yeah, so I guess it needs double quotes, but that makes no sense why I didn't catch this and this. It makes sense that key works, but it doesn't make sense that these other values are not being removed from this data exchange server. See, I'm supposed to be removing passcode. So if I'm removing passcode, why is it still there? I'm not sure what RPC is going to do for me. Set data, I get the setting situation, fine, cool, great. Click to apply changes. It doesn't tell me I have to do anything to apply. It should automatically remove stuff from that. And when I reset the whole thing, the stuff is still there. New encrypted message, great. How come I can't remove these things? Still has the old passcode. Sometimes it feels like it doesn't work for whatever fucking reason. Clearly reset the code to the template. I guess these are like super general content or super general sets of objects. What if I do find? Forget first. Let's do find. Maybe I'm not. Oh, it is, because it's still printing it, so I am in the same place. It's still printing the same code, so that didn't do anything different. Weird. Okay, so if I go back to the menu. What if I go back to the menu? Or just change? Let's change to this. And then go back to hacking packet sniffer. I know my code's still there, but let's see if the data warehouse is still the same. Okay, see, now data's reset. Why is that doing it that way? Alright, fine. So now we have a correct decryption process, so we should get a single star at least. And I really do think, yeah, I think I have to crack it manually, meaning that instead of using the function or method try decrypt, I need to create my own algorithm to move each letter up. Which I can do, I just have to figure out what the valuations are for each character. There it is, passcode. That's the way you want it. Submit the correct passcode into the data exchange with key. I did. Okay, do I need to... Huh? I'm so confused. Okay, so now that it's in there, does that mean I just data exchange dot uh-huh. What? How can you tell me there's something called that I can copy? Store big data. But is that just a regular function then? Is that not a method inside? Makes no sense. It's not defined. Yeah. So how can you tell me this exists? Copy the code. Considering we're in the data exchange object. Okay. Hints. I just realized I speak English. How may I help you? Big data exchange. Hold on. Well, I sent the key and passcode value to the data exchange. It now shows, is this an AI? Actual AI? That's pretty cool. Data, passcode, 66957 from the decrypted message, but nothing is happening. What? What do you mean? Sorry? I didn't say anything wrong. The f is this? Assistant? I sent the data, but nothing is happening. Okay, this is useless. Oh, what the hell is this? While you ask assistant anything, it is only good at answering a set of predefined questions. Start typing to see. Oh, well, okay. I get it. It's kind of like not an AI. I said. Data exchange, data exchange, data exchange. Nothing that I can use here. Our expert system. Expert's a very, very long-winded way to say useless. Okay, so what does RPC do then? Data x dot RPC. It's a setter code. So we're setting something in the store, but it's empty. So we didn't really do anything, which is, I guess, fine. Okay, how about I found a bug? That's true. I can go to the Discord, but I don't really want to. Open full pie job in your browser. Let's see. Data exchange. Alright, I guess we're reading these now. Set template, set current money. Well, they did at least because, I mean, there's a lot of options here. Entity class. Wait, what? There's a class, alright. First, editor set read only true. Okay, get data, we get this idea. Load big data, load and retrieve a big data set from a remote storage. A bytes IO stream, okay. React to a remote procedure call. Callable forward data exchange RPC invoke. Okay, remove data. That didn't quite work. Not very effectively, at least. Return result for a given remote procedure call and store it in this data exchange. Okay. Available RPCs depend on the current level and should be explained there. Give me an example. Function name string, name of a function to call, position arguments to pass the function. So function, self, function name. So considering in Python, anytime there's a class, normally the first implied input, so it's going to be self. Self is a reference to the object that's being used. In our case, this guy, data x, that's going to be considered the self in this situation. We don't normally use it, it's created that way. These are the examples that we got in game. I mean, this is like, that's it. Can I just not use this to remove data myself? Set string, remove data, key true. Closed door, we did that one. Delivery, self, we did that. Oh my god, this is weird. There's your flipping passcode. I did. Here it is. Here's your finale. Just the rest of it's weird. I submitted the passcode. Unless something doesn't match. Did I put an extra space somewhere? Is it because it's a string? Is it because it's a string? I think because the quotes around that particular passcode here, it's actually looking at it as a string instead of a number. Let's do it one more time. Okay, because I put it in as a string. Fine. Alright, now let me attempt to do this by hand. So the problem then for the extra points is that I'm using this try decrypt process here. So symbols and all that jazz included, I can easily convert the letters. I might also be able to look up the actual values. And it is also capital and lower K. Is it? I think it would. Oh, that's tiny. I don't know if this is gonna be the one. Character imprintable. So these values so let's make a function called decrypt message or define. And then here I need a array of values that's gonna basically mimic this. I don't like this. Hold on. Just bigger, cleaner. It is. So really they all start from space, exclamation. I don't want to manually copy these. Here's the case, exactly. These are the decimal ASCII values. We're adding ones, shifting them to the next value. So 98 would be B, 99 would be C. I can do it with the decimal ASCII. I can also do it with an array. That goes through the values given. And then just shifting it manually in the array that I'm creating. So I can create basically an array with these values, all of them, which is very annoying. Which means maybe I'll find a text. ASCII decimal table. Let's see if I can JSON. Aha, that's nice. So really my only interest is this here. Otherwise, I'm gonna go far beyond and do things that I don't need to test, like 300s. All of those. We don't need to test all of these extra. I mean, in normal situations, you probably would. Oh, so that's the hex value. Well, it's better than doing it by hand, I suppose. Let me see. ASCII decimal. So using this, a single quote add 1 goes to 28. The highest value, oh gosh, 176. Other than the fact that I'm going to be following a valuation at 40 going to 176, so my loop is going to be a little bit interesting. But I can try and decrypt it here in the second script space manually. Okay, so encrypted message equals to message sniffer dot underscore, oh no, find underscore entity message sniffer 0. So it looks like we're using basic ones. There's no crazy Latin accents, just Q, parentheses, asterisk. Those should be all in here, right? But then there's gotta be. I don't know if I need to use this whole thing because there's a Python way to decrypt this. Python ASCII. Number ordinal. Oh, yeah. All right. So CHR for character, ORD to the number. And then I would need Python string to character array. Technically should be. It's just list. All right. So I don't need to go this crazy far. We first take the message, put it in a list, call this the message array. So for character, let's do a full one, in message array. Can do char. Yeah, it's not a reserved keyword, so that's good. Or we can do message char and message array. Create a new array. The new array dot push. Let me see. Python push. We gotta push individual values onto the array. Append. So append. And then I need to make sure I put in the sub key that I'm moving by. And because key is going to change out here, I need to give it the key from the outside of the function. And we're going to take message char ord, change it into a value, add the key, and then change it back to a char. Does that also mean that in Python I can change it back to a string with a str? Oh, we can also map them. We can check it out. So after we increase each individual value by the key, then I guess we can print str of new array. Should automatically convert it. And that should not break and decrypt. This optional goal should still function. Then we can return the new array, the string of that new array, just assuming that it's going to convert to a string. And then continue. The loop. Decrypted message. And then it's going to check if we find good luck in there. It worked before. I literally had decrypted message here. I guess maybe I just want to put a decrypted message empty string. Wow, where am I going? Just to have it exist in the global. Something's not initiating it correctly. Oh. What? Where? Line 23? Oh, wait a minute. Encrypted message. Right, I need encrypted message there. I don't need this. I put it in the wrong place. And then what's this? Line 17? 17, yeah. 17 CHR? Is it CHR? Hold on. Uh-huh, it is just CHR. Right there. It's not iteratable. Okay, because why? Ciphertext. I have to extract, okay, because before it was just doing it within the object itself. So here, encrypted message, I'm gonna have to extract the get ciphertext instead of leaving the object as its whole. Okay, okay, okay. Kind of. No. Yeah, some of them are working out. Other ones are doing weird stuff. It's kind of doing it. Okay. Yeah, close. But then some of them are weird. Huh? But really, they're not printing a string, which is a problem. I'm never gonna find it this way because good luck is not gonna be presented perfectly here. Okay, so then I gotta go back to Python, array to string. A list to a string. Oh, dot join. Yeah, okay, I forgot to use that. So instead of doing layos, we do a dot join. And we return dot join so it doesn't look so messy. So that does make sense. I'm currently doing it in a quote-unquote offline. Oh, wait a minute. It's not that way. I need to create a string and then do dot join of the value inside. String and then dot join. There we go. Give or take. We'll basically be going through every single character this way. I could probably reduce the valuation knowing that I'm focusing on real text rather than symbols and all the extra keyboard key values by flipping what I already know about the full extent of that. It was like 170. If the value is greater than 170, change it to 40 sort of thing, which is going to be somewhere in here where I can do that. But let's see how long it takes with this method. Just a straight brute force every single symbol in the ASCII. We have 300 of them. So I'm just going to let this run for 300 plus and I'll be RB. We're getting close. Oh, we're going through all the. Oh, jeez. Oh, that's annoying. I don't even know how many key values we've gone through so far. Did not print the key value itself. Well, we'll give it some more time.
Code cracking the fingers, dancing on the keys. Matrix in my head, breaking locks with ease. Underdog hacker, ghost in the machine. Digital overlord, ruling screens unseen. Rise up from shadows where the wires hum. They ain't see me coming, I'm the quiet one. Flipping scripts, algorithms on my tongue. The game's been hacked, the war just begun. Game's been hacked, the war just begun. Blood flows like data streams, binary dreams. Life ain't what it seems. Outsiders anthem, rebels raw fight. Shadows at my back, I chase the neon light. Encrypted whispers, they quiver in fear. My name written in codes you'll never hear. The rise of the silent, breaking through traps. Old school vibes blend with new age hacks. Motherboard soldier, army of just one. Taking on giants, battles never done. Trojan horse tactics, slipping through cracks. Building empires with no looking back. Rise up from shadows where the wires hum. They ain't see me coming, I'm the quiet one. Flipping scripts, algorithms on my tongue. The game's been hacked, the war just begun. The game's been hacked, the war just begun. Just begun.
Remember, the first century had not. Matter of fact, that's the same. Wait first, or the clock strings.
Ethernet veins, blood flows like data streams. Binary dreams, life ain't what it seems. Outsiders anthem, rebels raw fight. Shadows at my back, I chase the neon light. Encrypted whispers, they quiver in fear. My name written in codes you'll never hear. The rise of the silent, breaking through traps. Old school vibes blend with new age hacks. Encrypted never hear the rise of the silent, breaking through traps, old school vibes blend with new age hacks. Boy soldier, army of just one, taking on giants, battles never done. Trojan horse tactics, slipping through cracks, building empires with no looking back.
Oh my god, it's still going? Alright, so it might be easier just to simplify this a bit. So instead of doing it this way, well, improving on it, we're gonna take the message car, or if the order ASCII value of the message car is greater than 176, then we will this is gonna adjust some things for us though. It's always going to start at the same value each time. I'm going to have to return the encrypted message to itself and adjust the encrypted message each time. So my logic in the while loop is going to change a little bit. Oh, so if it's greater than 166, then we're going to change the message car to 40. The key is still going to increase a long time forward. So the key might have to be managed by the decrypt method. So that'll reset it back to the beginning of our list at the space. But I can also make the while loop do that for me. This is going to be a little bit more than I thought here. We're going to set the message card to 40. Which means that I wouldn't have to increase the key here if I do it in here. God, that was a long time running, huh? So many characters. So if it starts at 40 again, I don't want to increase it by the key value because that's going to be like 100 and something. Key should always be 1 because if we do it this way where we encrypt message and encrypt message, So if we keep redoing the encrypt or re-saving back into the encrypt message, we're saving the next increment of the key adjustment. Which means we don't need a key upgrade. We won't need the key here. We won't need the key here. The key is just gonna be a +1. And then we can actually take this new array, throw it here, and just do 39 for the -1 location, because it's gonna add a 1 anyway. If it's not greater than 176, it'll continue running, going through. And that'll push whatever goes above 146 back to 40, and then reconfiguring, rebalancing from the beginning, starting over. Is that all I need? We'll do a else, so we don't want to do it twice. And let's try that. I'm keeping track of this one. STU Z symbols, and then back to space. Oh, and then you have the actual capitals, true. Line 18. Int not found. Expected a string of length 1. Oh, I think I need to do a +1 in here, rather. No, wait. Oh, wait. I'm doing this here. I need to do the ORD out here. Hold on. Message car. If ORD of message car is greater than 176, we don't want to change, right? We don't want to change to 39. Kind of do though. But then we already have the ORD here, so I don't need this anymore. This is odd. Using the same variable in this format. So maybe I should just not do this, and I should just do 40 in here. A 40 just to change it to the beginning and convert it to a value. So symbol, symbol, symbol. It's kind of getting there. It's not stopping, which is good. Interesting. We're getting a lot of new lines and symbols that are representing extra spaces and enters. Okay, so there we go. A, B, C going. It's not. Oh, okay. Yeah, I think it's going good now. T, V, W, X, Y, Z. Then it goes to the next, and then it's going to go to the lowercase. There it is. This first digit is keeping track of things. But now it's gone. It's a symbol not visible. Looks like it's gonna overlap again. Numbers, symbols, back to uppercase. So they're not all moving in the same increment or something? This is gonna be a much deeper issue here. I don't think it's gonna work. It looks like it's just looping over. Oh. Well, I got 1 star on this though. And back to the ADCs. Alright, well, that's gonna loop forever, it looks like. Alright, let's do another one. We got a star. I'm cool with that. The bugged phone. We have a bugged red phone booth to be able to intercept which number is being dialed. And then take audio data and reconstruct it. Ugh. Get the raw PCM audio data of the number of tones we just dialed. Meh. Well, actually, let me see. It seems like we actually have to convert audio.
What you see down here, it's quite
Right, last number audio values. Okay, so the tones are values. Oh, well. So I can essentially save these values for one. With a very slight adjustment to each dial tone. Looks like 10, 9, 8, 7, 6, about 5. 2, 2, 2, 2, 1, 1, 2, 1. Zeros down here. So I can basically save these values with the dial tone. And then reconvert that value once I dial a number, identifying which of the array values are present. I think I'm done for now though. This was pretty fun. Very, very puzzling. But continuing forward in the future. For now.